now. All right, so G period, this is for you. Happy snow day, happy e-learning day. We were supposed to learn something else today, but I thought it was going to be too hard to do on a video, so we will learn that tomorrow. So we're going to do a little bit of skipping around today in these notes. So just thank you for your patience. Thanks for kind of oh, come on, log into my iPad. Okay, there we go. Thanks for being flexible. Sorry, it's not going to lead up exactly like what I'm doing in alpha, but we'll get caught up with them in the next couple of days. We are going to use calculators today because that's kind of what we have available that we are allowed to use, that I don't need to teach you new things of. And we're also going to do some of this trig functions like we did the last class. So if you don't have this written down or don't remember this, this is going to be important to a few things that we're going to do today. So you need calculators, and then you need to have this either written down, memorized, taken a picture of, all of that fun stuff. Okay. And again, we're going to be a little jumpy around, but this should not take a whole class period just because we really needed to learn what we needed to learn today, the unit circle, but I can't teach that to you yet. So we're going to jump down in 4.2 and we're going to go to number 4. We can do number 4 without any new knowledge that I wanted to teach you guys today. So I'm going to pull my calculator up. And I'm actually going to jump around even on this problem a little bit too. So we are going to start by doing the ones that look familiar to us. We're going to do cosine, we're going to do tangent, we're going to do sine, and then we'll come back and do secant, cosecant, and cotangent. So actually the first one I think is the easiest one, this cosine one, cosine of pi over 9. The first thing I want to think about is this radians or is this degrees? Okay, is this radians or is this degrees? And we know that if it has a pi in it, it's a radian. Like I mentioned the other day when we were putting things in the calculator, you need it to be the same language. So if we're putting radians in, we need to be in a mode of radians in our calculator. And so we, through this whole problem, are going to be switching back and forth, radians, degrees, radians, degrees. So I'm going to go mode right now, and I want it to be in radians because for letter D, the first problem I'm going to do here, that's a radian. So I want my calculator to also be in that. Then it's as simple as just plugging in exactly what you see. I'm going to press cosine of pi divided by 9, and I'm going to press enter. On these, let's run to the 10,000th place, which is 4 places after the decimal. So I'm going to make that 0.9397. Okay, so that one was a radian, so we were in radians. Now, if I look at both B, which is a tangent, and then E, which is a sine, those are in degrees. So we're actually going to go move our calculator immediately back to degrees. So I'm going to go to mode, degrees, press enter, and then second mode, quit out of that. However, I am going to have to do a little bit of work before I go ahead and plug these into the calculator. If you remember back in, what was it, section 4.1, when we made our degrees, minutes, seconds into decimals, we want to make this 28 degrees and 11 minutes into 28 degrees and point something of that degree. Let's make our 11, that's in minutes. So we want to divide that by 60 minutes in order to get it into degree. Minutes divided by minutes cancels out. So 11 divided by 60 is going to be 0.18333, and we'll just round that like we've been rounding everything to 4 places after the decimal. Okay, now we're not done yet though, because we don't just want what the decimal form is. Now we want to do tan of this. I want to do tan of that angle. We did just change our mode to be in degrees, but if you're not sure, go ahead and go back and check. So I'm going to press tan, and then I'm going to type 28.1833. That's in degrees because I told my calculator we're in degrees, and it gives me out this decimal. So my answer here is going to be 0.5358. Okay. So again, we're using our skills from chapter 4.1 to make that degrees, minutes, seconds into a decimal degree, and then we're doing tangent of it. Now we're going to do the exact same thing for sine, but we've got a couple more steps before we can just plug it in. So I need to make that 11 minutes into a decimal and my 13 seconds into a decimal and add them together. So we'll do 18 minutes divided by 60 minutes. That's 1 degree. minutes will cancel. 18 divided by 60 is 0.3, okay? And then we're gonna make our 13 seconds into a degree as well. So 13 seconds, remember that that conversion is 3,600. 3,600 seconds are in 1 degree. So we're gonna divide 13 by 3,600. And we're gonna get 0.0036. And that's probably good. That's 4 places. Okay. And again, just like the other one, we're not done because we did our degrees, minutes, seconds. Now we want to do, we have 29 point, let's add that 0.3 plus that 0.0036. So we get 0.3036. We don't just want that number, we now want to do the sign of that. So we're going to go press in our calculator sign of this number. Sign 129.3036. And we've been in degrees because I was in degrees earlier. You can always go press your mode and double check. And we're going to press enter. And we get 0.7738. Okay. All right. Any questions with that? Okay. All right. Now we're going to do the 3 that I did not have highlighted. We're going to do secant, cosecant, and cotangent. I'm going to roll back up in my notes because I want to remember that cosecant, secant, and cotangent are what I call the reciprocal functions. Reciprocal means that we flip them. Another way to think of it, so we flipped like the OH to make it HO. You can also think of this as cosecant being equal to 1 over sine. And secant is going to be the same as 1 over cosine. And cotangent is the same as 1 over tangent. We do not have secant, cosecant, or cotangent buttons on our calculator. But if I do 1 divided by like cosine, that's going to give me the same thing as secant is. What a lot of people want to do is second cosine, but if you remember from our notes earlier this week, when we were doing those word problems, like this one right here, we use second sine or second cosine or second tangent in order to find an angle. We're not trying to find angle when we do cosecant, cotangent, and secant. We're trying to find the ratio. So we're not going to do to the negative first. We're going to do 1 divided by whatever trig function we want. So let me go back to the problems that we were looking at. So let's look at secant. So if I'm looking at secant, that's in degrees. And so that's why I'm writing blue. I'm trying to color coordinate this. Secant is the reciprocal function of cosine. So secant is going to be 1 over cosine of 10 degrees. And so that's what we're going to go put in our calculator. 1 divided by cosine of 10. Now, if you're like, I have no idea what mode I'm in, go back and check. I believe we're in degrees. Okay, we still are in degrees, so I'll second quit out of that. So 1 over cosine of 10, and that is going to give me my answer here. So that is 1.0154. So the special thing we did here is we don't have a button for secant, we put 1 over cosine, and we're about to do that for cosecant and for cotangent. Okay. So now I'm looking at my cosecant one on letter C at the very bottom of this page, cosecant of 5 pi over 16. Well, we actually know 5 pi over 16 is in radians, so we're going to want to switch our mode. You can do that in a minute, or you can do that now. I'm going to do that right now. Mode, I'm going to make that be radians, enter second mode to quit out. And then I have to remember that cosecant is the reciprocal function of sine, so it's 1 over sine 5 pi over 16. And so now we can go press that. My mode is in radians, so I can press 1 divided by sine. All of this is inside parentheses, so I'll just do 5 pi divided by 16. And I get 1.2027. 1.2027. Anybody have any questions yet? All right, last one of this type at least is cotangent of 2. Now this one's a little bit tricky. I'm going to tell you that 2 is a radian. And my question to you would be like, do you know why I think that's a radian? Notice that I don't have a degree sign. So it's just like a 2 by itself. There's no degree up here. Yes, I know that most of our radians have pi's in them, but it doesn't have to have pi. It just can't have a degree sign. So this is a radian simply because there's no degree sign. I'm going to do this just like I was doing everything else. I know cotangent is the reciprocal of tangent. So I'm going to do 1 divided by tangent of 2. Make sure you're still in radians. I can tell by the last problem, I have not switched my modes. I was in radians before, but you can always click your mode and double check. Okay, I'm still in radians. 1 divided by tan of 2. And I get negative 0.4577. We're going to do, when we learn the unit circle, we're going to be doing a lot more with the sine, cosines, tangents. So you'll kind of get used to seeing like what numbers make sense. It's okay to get a negative. It's okay to get a decimal. It's okay to get a number bigger than 1. We don't often have that, but every so often we do. So those are kind of rules that we'll talk more about as we dive deeper into this chapter. Okay. That was a little bit of calculator work. We're going to jump to the beginning of 4.3. So nothing else we can do right now. The rest of it is requiring our unit circle, which I would have liked to do today, but we'll do next class. And we're going to jump and do A and B and number 2 of this problem on 4.3. So these say evaluate the 6 functions of theta. These problems look a lot like the ones that we did earlier in 4.2. The difference is that it's not just a triangle. Now I'm giving us, we're looking at angles. We're looking at angles in standard position. If you remember back in 4.1, I was telling you guys about standard position, where one of the rays of an angle is always on the positive x-axis. And then the other, we call it the rotating ray, is somewhere else on my picture. And it always goes counterclockwise from the initial ray around to the rotating ray. So it looks like this angle is a little bit bigger than 180 degrees. We can still do sine, cosine, tangent, all that fun stuff on it by looking at this figure that I have here. Okay. Now, since it's not a pretty triangle like we're used to, we're still going to make it a triangle. Something I am going to teach you or talk more about to you guys about tomorrow is something called bow tie angles. Bow tie angles is exactly what you think. It's going to look like a little bow tie. So I'm going to draw like a coordinate plane. And if I don't have a pretty triangle like we did back in 4.2, I'm just going to zoom out for a second. And I actually don't need that calculator right now. If we don't have like a pretty triangle like these things that we were looking at in 4.2, or even like this, where I told you it was in standard position, but we just stayed in the first quadrant. If we don't have a nice pretty angle like that, we're going to draw a bow tie angle, which just means that my triangle is always going to have one side on the x-axis, and then the angle is always going to be like the closest to the origin. So like that's an example of a bow tie angle. This is a pretty one. A not as pretty one is if I go in the second quadrant, I still want to have one of my legs be on the x-axis. And then the theta, the angle you're looking at, is closest to the origin. In our example, we're in quadrant 3. So our angle is going to have its, like one of its side is going to be on the negative x-axis, and then it's going to go down into the third quadrant. And my theta is going to be again close to the origin. My right angle is touching the, like the vertical distance, and my leg that's on the x-axis. And then the last little bow tie would come down here in the fourth quadrant. So when all of them are together, it kind of looks like a bow tie. Some people call them butterfly angles. So whatever makes you happy, you can call them that. But when we're looking at angles that are not necessarily clean cut in the first quadrant like we're used to seeing, we're going to draw them here. So I'm going to just jump over to the example that we're looking at in this picture. The bow tie angle I'm going to draw is going to have one side be along the negative x-axis. I'm going to jump up to the point, and then I'm going to go along that hypotenuse. So I'm looking at this yellow triangle now. The theta is all of it, but I'm only worrying about the reference angle, so I can label this angle in here theta, and it's referencing the same thing that all of the angle is referencing. Now, the reason I drew this triangle is because now I'm going to use its x and y and label the sides of the triangle. The x is the left and right, the horizontal distance. So this distance right here is my x, that's my -3. So from here to here is -3 units. And then my -4 is my y, which is my vertical distance, which is over here. -4 goes from where we were on the x-axis all the way to the point that we're at. Now that we have this is a triangle that looks like what we did the other day. We can find that missing side using Pythagorean theorem again, and then I can label all my sides adjacent, opposite, hypotenuse, all that fun stuff, and I can figure out what all my sine functions are. So the hardest thing is just taking the picture that was given to you and drawing your reference angle and labeling it. Now that I have it labeled, I know that I've got one side that's -3, one side that's -4, and then I want to find my hypotenuse. So I'm going to do my work over here. -3 plus -4 squared equals c squared. Put little parentheses around your negatives because any negative or any number squared is going to be positive. So I get 9 plus 16 equals c squared. Add those together, I get 25 equals c squared. And then we can square root both sides or both parts, and I get c equals 5. I don't know if you noticed, but I want you to recognize that both of my a and b were both negative numbers. That's okay. Your a's and b's can be negative or positive, but your c, your hypotenuse, is always going to be a positive number. So in this case, it's 5. Now that I've done this though, I know where theta is, I'm going to label opposite, hypotenuse, and adjacent, and I'm going to do my sine, cosine, tangents, cosecant, secant, and cotangents. If it's helpful to you, write your OH, and do all the reciprocals, HO, HA, AO. If you don't need to write that, you don't have to, it's okay. Go ahead and just write the actual numbers. So my sine is going to be -4/5. My cosine is going to be -3/5. My tangent is going to be -4/-3. But we know 2 negatives will make it positive. So +4/+3. And then now we flip all of them. So I get 5/-4. That's messy. We get 5/-3. And we'll get -3/-4, which we know will become +3/+4. Okay. All right, we've basically got 3 more problems just like that. One of them has a picture drawn for us, the other 2 don't. I'm still going to walk you through this. If you feel like you got it, go ahead and pause it and just keep trying this problem and then jump ahead to catch up with me with your work. But in case you don't understand or you're still struggling, I'm going to walk through all 3 of these together. Okay, so now I'm doing my bow tie angle, my reference angle down here in the 4th quadrant. I'm going to model it after this one right here. One of my legs is going to be on the positive x-axis. Then I'm going to go up to the point. Oop, I'm a little bit off, I guess. Up to the point. And then the hypotenuse along the middle. Your theta is always by the origin. Your right angle is always like touching the x-axis. And now I want to use the points that were given to me. 3, -2. 3 is my x. So that means 3 is my horizontal distance, and then -2 is my y, so that's my vertical distance. Now we want to find out what my hypotenuse is, what my c is, using our Pythagorean theorem. So again, A and B don't matter, but C is always the hypotenuse. And in this case, we don't know what C is. So I'm going to do 3 squared plus -2 squared equals C squared. 9 plus 4 equals C squared. 13 equals C squared. And then square root. Square root of 13 is going to be, oh, that's good enough. I don't even have to simplify that. So radical square root of 13. So we drew our bow tie angle, our reference angle, then we labeled it, and then we found the missing side. And then now we're just ready for our normal opposite adjacent hypotenuse, opposite hypotenuse adjacent, and we're going to go find our sine, cosine, tangent. Again, in case I forgot, I am going to label my OH, A, H, O, A, and all my opposites, H, O, H, A, O. And I'll plug in those points with it. We'll go -2 over root 13. I do want us to rationalize that, so let's make it -2 root 13 over 13. A is going to be 3 over root 13, which is just 3 root 13 over 13. And then tangent is going to be -2 over 3. We doing okay so far? Okay. And then now we'll do our cosecant, secant, cotangent, just flip them all. So that becomes root 13 over -2, root 13 over 3, and 3 over -2. Now, I know I keep saying like 3 over -2. That negative's just with the whole fraction. So you can put the negative up with the 3. You can put it just like in between so that both of them get it. You can put it on the bottom. It doesn't matter, but only one of them's negative. So that's why the whole fraction stays negative. So just a little reminder on that. So those are my answers. Okay. The next two problems are just like this. The only difference is the picture is not drawn. So we have to draw ourselves a picture. In the first A and B, it was labeled for us. Now it's describing the same thing. It says point P is on the terminal side of O in a standard position. Find the values of the 6 functions of theta. Oh, why did I call that O? I'm so sorry. Theta, 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 theta. So like, let me draw the first one. When I start to draw these, I'm going to draw my coordinate plane, just a normal XY axis. And then it says we want to find the point of 2, -2. So I'm just going to go on my picture and I'm going to draw that point on here. So I'm going to go +2. Oh, let me give some dash marks. So we're going to go +2, -2. And that's that point right here, 2, -2. And so from here, you can draw the ray this way. You don't have to draw this. You can just watch me. You can draw your angle and draw the little theta all the way around. I don't technically need that. All I really need is just the reference triangle. So I'm going to draw my reference triangle like this. Oh, that was so bad. Notability couldn't even save me. There we go. Let's try again. There we go. Okay. So just draw a reference triangle in the 4th quadrant. Remember that one of the sides is always on the x-axis. Never, ever have we drawn them on the y-axis. Never, ever will you draw them on the y-axis. Always draw them on the x-axis. Theta, right angle, label our sides. My x is 2. My y is -2. And then I don't know what my c is. So we're going to go Pythagorean theorem and solve that. A, B, C. 2 squared plus -2 squared equals C squared. Oop, there we go. 4 plus 4 equals C squared. 8 equals C squared. Ooh, for the first time in a while, we are gonna simplify root 8. Root 8 is the same thing as 2 root 2. If you forgot how I did that, do your little factor tree for 8. 8's 4 and 2. 4 becomes 2 and 2. The pair comes out. The single guy stays inside. So 2 root 2 is my C. It's my hypotenuse. It's my missing side. The only issue this is really going to cause for me is the fact that I'm going to need to have some simplifying as I go. I'm going to label my O's, my H, and my A. And we're going to do sine, cosine, tangent, etc., etc. I know that this isn't the exact same way that I set it up, but I still have everything lined up. So like sine goes with secant, cosine goes with secant, and tangent goes with cotangent. So just a reminder, that's how they match up. Sine is O over H, cosine is A over H, tan is O over A, cosecant is the reciprocal of sine, so H over O, secant is the reciprocal of cosine, H over A, and cotangent is the reciprocal of tangent, A over O. So we're going to take our picture and find all of those. So opposite -2 over hypotenuse 2 root 2. Again, I told you the simplifying is going to be annoying here, but the 2's are going to cancel out. So I get -1 over root 2, but you can't have a radical in the bottom. So we're going to keep rationalizing, multiply by root 2 on both sides, -√2 over 2. Now, if Alpha was watching this, they would recognize that number because we've talked about that with the unit circle. You guys in G period, we haven't done that yet, but like root 2 over 2 is going to be a number that we're going to talk about a lot in the near future. So kind of hold that in your brain. A is +2 over root 2, exact same, 2 root 2, excuse me. Carry that 2 with you. Exact same idea. The 2's are going to cancel out. Let's multiply by root 2 on top and bottom. We get root 2 over 2. Tangent is opposite over adjacent, -2 over 2, which is just -1. And then now we're doing all the flips. So cosecant is H over O. So 2 root 2 over -2. The 2's are going to cancel. So we're left with -√2. H over A. H is going to be 2 root 2. A is 2. Again, the 2's cancel. This is a positive root 2 this time. And then last but not least, just like before, A is 2, O is -2, so we get -1. So tangent and cotangent happen to be the same number this time. Okay. Anybody questions on that one? All right, the next one is just like that. Go ahead and start that. I'm going to work with you in 1 second. And then we just have a couple more problems and I'm done for today. All right, so let's go draw this picture. -1, +4 is over here. Oh, that's a really skinny triangle. Oh, well. Sorry, he's so skinny, but that's what that triangle looks like. So angle theta, oh, almost too small. There's my theta. And again, we know that our point was -1, +4. My x is -1. My y is 4. And then we don't know our c. So we're going to Pythagorean theorem, just like we keep doing. A, B, C. I'll do that down here. -1 squared plus 4 squared equals c squared. -1 squared is 1, 4 squared is 16, c squared is going to be 17. So square root both sides. Ooh, this is nice. We do not have to simplify because we can't simplify root 17. Come on. So again, we've drawn triangles in all sorts of different quadrants in the first, second, third, and fourth, and all of them have had positive x, positive c values, positive hypotenuses. So they will always be positive hypotenuses, even if the x or the y is negative. All right, now we're going to find all of our trig functions. Here's my opposite, here's my adjacent, here's my hypotenuse. Go ahead and fill those in. OH, AH, OA, HO, HA, AO. Okay. Opposite is 4. Hypotenuse is √7, so 4 root 17 over 17. Cosine, -1 over √17. You don't need that -1 out front. Negative √17 over 17. And then O over H is 4 over -1, which is just -4. Cosecant is going to be √17 over 4. That's good enough. Secant is √17 over -1. I will make that negative √17. I'll just get rid of that denominator of a -1. And then last one, -1/4. That works. Ooh, come on. All right. Okay. I want to kind of skip to almost the very, very end of this chapter. And we're going to do one more type of problem. It's just one more calculator problem, and then we are done. So we are going to skip to the very end of 4.5. So we're going to number 3 on 4.5. Oh, shoot. No, we will not do coterminal angles today. We'll do that another day. We're going to skip. It's a lot. So go past 4.4. We're not going to do any graphing yet. Go past the beginning of 4.5. We're going to go do number 3. It says solve with the calculator. All we're going to do is put this in the calculator. All we're going to do is use the inverse trig functions in order to solve. Just like in our word problems the other day, in order to get x by itself or the angle by itself, we want to do inverse of tangent to get rid of that. So x is going to equal tan to the -1 of 1.75. And we can just put that right in the calculator. Now, one thing it does say is 0 is less than or equal to x, which is less than 2 pi. That means I want it in radians. So I'm going to make sure my calculator is in radians. Let me get my calculator back up. So mode is radians. Okay, I'm good on that. I'm just going to type second tan to get tan to the -1 of 1.75. And my answer is 1.05 radians. We'll just go 2 places this time. X equals 1.05 radians. Okay. The other two look a tiny bit more complicated because it's not just tan or sine or cosine. We have to do, we have to think of it, we have to put it into a sine or a cosine first. So remember that cosecant is the same thing as 1 over sine. So 1 over sine x is equal to 7/3. In order to make this simpler, I'm going to essentially flip both of my fractions. I'm going to do the reciprocal of this is equal to the reciprocal of that. If I flip one side, then that's the same thing as flipping the other one. So sine of x is just going to equal 3/7. Now that it's in this form, I think it's pretty easy to see that we're going to do our inverse sine of both sides to get x equals inverse sine of 3/7. And then we can put that in the calculator. And again, our problem is still in radians. The hardest part here is that you have to remember that cosecant is the same thing as 1 over sine. And then if I want to flip this to be a normal sine, I need to flip that to be 3/7. So we just reciprocal, both sides. So let's go second sine of 3 divided by 7. Enter, and we get x equals 0.44 radians. All right, last one is a lot like letter B, so I'll kind of keep it so you can see both of them. We know that secant is the same thing as the reciprocal of cosine. So we'll say 1 over cosine x equals -3 over 2. And just like the last problem, I want it to be a normal cosine. So that means I've got to flip my fraction. So we'll say cosine of x equals -2/3. And then just like the last two problems, to get rid of the cosine, we're going to do inverse cosine. So x equals inverse cosine of -2/3. Second cos -2 divided by 3. And I get x equals 2.30 radians. Okay. That is about all we can do until I teach you unit circle, which I will tomorrow. So that is it on the video. You have no homework. This is not necessarily needed to learn tomorrow's lesson, but this is all I could teach you until I get through the unit circle. So that is it on this lesson.